What you got, buddy?
Will there be a test in trig or not?
No, we're going to finish with the project. It's thinking right now. All right, there we go. Okay, guys, so we're going to go ahead and kind of extend what we did on Thursday, which was about angles of rotation, and really learn our main trig lesson today, which is over the unit circle. We will have to use some of the stuff we learned about angles of rotation on Thursday today, but really this is kind of its own thing. Okay, and remember what we're gonna do is kind of finish out this week before spring break by talking about these trig lessons and mainly focus on the unit circle and finishing up with that project that I've kind of referenced a little bit. Okay, so let's get into talking about the unit circle and kind of what it all means and all that good stuff. Okay, before we do that though, you guys just filled out the unit circle. And one of the measures you probably noticed that made sense were the degrees, but there were also these other measures, and those were radians. Okay, so it says, in addition to using degrees as a unit of measure for angles, angles can also be measured in radians. And then geometry kids, let's see if you can help me with the next thing. I couldn't figure out what would go in the next blank, but it says a radian is a unit of angle measure. Any thoughts on what could go there? I didn't know. I was a little lost on what might go there, but maybe we'll figure it out later. But for now, we'll just leave that blank. But let's go ahead and look at kind of a diagram of our four kind of our coordinate grid and its benchmarks in radians. Okay, so we've talked a lot about this guy is 0 and 360, this guy is 90, this guy is 180, and this guy is 270. But what about those in radians? Okay, so 0 is still 0, right? 0 degrees is 0 radians. But what about 360? What is that in radians? That would be 2 pi radians. So a full turn is known as 2 pi radians. Okay, 90 degrees is equivalent to pi over 2 radians. 180 is equivalent to 1 pi radians. And then 270 is equivalent to 3 pi over 2 radians. All this pi talk on Pi Day. Look at that. Well, we are celebrating Pi Day. How else would you want to celebrate Pi Day but talking about degrees and radians? I know, but you guys know I'm not that guy. Let's not kid ourselves here. You're barking up the wrong tree if you're looking for Mr. Jenkins bringing in pie. You wouldn't even want a pie that I baked anyway. So that's true. All right. So how do we kind of measure something in radians if we're given a degrees? You use this or a measure in degrees. You use this conversion factor. It is pi. Sorry, am I giving you the back? Yeah, pi over 180. All right, and then to go back the other way, to go from radians to degrees, we do just flip it, 180 over pi. All right, so let's go ahead and practice that and looking at some equivalencies between degrees and radians. So in our first example, we will use those conversion factors to convert from radians to degrees and vice versa, okay? So in my first example, number 1 here, we're given a measure in degrees, so we're going to convert that to radians. So first of all, make sure we're using the correct conversion factor. That would be this guy here, okay? So we want to take 60 times pi over 180. So that is just 60 pi over 180. And then so all you're doing there is just reducing 60 over 180, okay? So that reduces to 1 over 3. So we get 1 pi or just pi over 3. So pi over 3 radians is equivalent to 60 degrees, okay? I'm going to leave B and D for you guys, so let's go ahead and try C. So now going back the other way, we need to use the other conversion factor. So now we're going to multiply our radians, degrees measured in radians by 180 over pi to get it to degrees. Okay, so this 2 pi over 3 times 180 over pi. All right, so on this one, you know, pi over pi is going to cancel out to 1 over 1, so you should just have numbers, not pi, or rational numbers, I should say. So now we're looking at reducing 2 times 180 over 3, or 360 over 3, and that would be 120. 120 over 1, or 120. Now, before you move on and try this on your own, notice the relationship in A and C, right? We said 60 was equal to 1 pi over 3, so it would make sense that 2 pi over 3 would be double 60, right? Which is 120. Okay. You go ahead and try B and D, and I'll put those up here in just a second. All right, so on B, we are kind of trying to reduce negative 135 over 180, right? That's really all we're trying to do. That's negative 3/4, so then my final answer would be negative 3 pi over 4. And then on D, just trying to reduce, you know, negative 5 times 180 over 6, that is negative 150. Sorry, negative 150. Just a quick reminder on a nice, easy way to reduce a fraction. So say negative 135 over 180. We can just type that in as a division problem, or a quotient, I guess I should say. Make it a decimal, and then, you know, we know that's negative 3/4, but if we didn't, we could go to math, fraction, and hit enter, and then there's your reduced fraction. Okay. All right, so now moving on to the big stuff here. So it says on the back side there, the unit circle based on special right triangles. Okay, so it is the unit circle is a circle with radius that's 1 unit, and for each point x, y, the value of the radius is 1. Okay, all right, so I don't really, honestly, I don't use this too much, because if we're using the unit circle, all this stuff takes care of itself. But there's this saying, all students take classes, or all students take calculus, I've heard before, that kind of gives you where each ratio is positive as far as their quadrants. Okay, so here's how you kind of use this. All right, so all goes in quadrant 1. So that's the whole word all. So all ratios, which is sine, cosine, and tangent, are positive in the first quadrant. Okay, all are positive. Students, all we take from that is the letter S, which is going to stand for sine in this case. So sine is positive in the second quadrant. Okay, so why don't we see if that holds real quick from our warm-up example. So before the video started, we did a warm-up where we found the trig ratios for this point P, which was in the second quadrant. We hadn't gone over any of this, but let's notice now what is positive there, right? sine is positive in the second quadrant, okay? And that's always true. All right, so then the rest of it goes, T is for tangent. Tangent is positive in the third quadrant. And then your last one, C, would be for cosine is positive in quad 4. Like I said, I don't use that a whole lot. If I'm using the unit circle, all that's kind of taken care of for me. So, but that is a generalization that's true. Okay. All right. So how does it kind of work? How's all this work? All right. So from our unit circle, our first kind of point that we look at, and we already filled this out, was up from here was square root of 3 over 2, comma 1 over 2. All right, so let's think about our trig ratios there. All right, so if I wanted to find sine of 30, we would do opposite side, right? Which is the y value in this case, 1/2, over the hypotenuse, which is always 1. Okay, so from the unit circle, 1/2 over 1 is, of course, 1/2. Okay, so what that tells us, or kind of leads us to see, is that it's always going to be opposite over 1. So sine is always the y value of your point. All right, for a given angle measure. All right, so what about cosine? You could probably guess what's next. So cosine of 30, that's going to be adjacent, which is this guy, right, which is our x coordinate, square root of 3 over 2, over the hypotenuse, right? So square root of 3 over 2 over 1 is just square root of 3 over 2. And so cosine, when we're using the unit circle, is always going to be your y value, or sorry, x value. All right, and we're going to add to this as well. What about tangent? What would that be? All right, so tangent, we're not going to worry about cleaning this up right now, but it's opposite 1/2 over adjacent. So 1/2 over square root of 3 over 2. So we're not going to, like I said, we're not going to worry about cleaning that up, but we are going to make a generalization. So that is, in the case of this problem, y over x. So that's how we find tangent as well. So I would add that here. So tan is y over x. All right, so now that we've kind of gone through that, and we'll just kind of skip the 45, 45, 90. I did some stuff on that on the notes, but let's go ahead and do our examples where we're using the unit circle to find some exact values. All right, let's just jump right on into it, okay? So based on what we just went over, we're going to find cosine of 210, right? So cosine, we said, was the x value. So I'd put an x above there. So x value for 210, okay? Then we just look at our filled out unit circle. Find your 210 degree mark. That's in quad 3. So 210, I want the x value. So then my answer to that question should be negative square root of 3 over 2. So cosine of 210 is negative square root of 3 over 2. Now, before we go on, make sure I'm on. Before we go on, you might wonder there, like, why would I need to use this unit circle and not just type it in, right? So what if I just type in cosine of 210? then I get that, right? So that's one of those where, okay, you know how to type it in, but do you know what that is exactly? So could you come up with negative square root of 3 over 2 from that decimal? No, right? So that's why we need the unit circle. But this is a decent way to check your answer, right? So I know if that's cosine of 210, then I could type in what I think the answer is. The opposite of the square root of 3 divided by 2. And I should get the exact same decimal, right? And I can see that I do. Okay, so that's a nice way to check your answer. All right, so now let's go a little bit quicker on these next few, because really these are quick problems, just finding stuff on the unit circle. All right, so on this example, we're going to find for 60 degrees, it's y value, because we're looking for sine here. The y value of a 60-degree angle. So we find 60. We know we want the y value, so square root of 3 over 2. Square root of 3 over 2. All right, and let's go ahead and why don't you find tangent of 135 real quick? Remember what we said, that was y over x. All right, so what you should have, your value should have been the square root of 2 over 2 was your numerator. Square root of 2 over 2. And then your denominator was negative square root of 2 over 2. Everybody agree with those values? Now, what about cleaning that up? Okay, it's not as complicated as it looks. You know, you can always set that up as the square root of 2 over 2 times 2 over, or negative 2 over the square root of 2. But, you know, make it simple when you can, right? Square root of 2 over square root of 2. I know I'm not saying that right, but anything over itself is 1, right? So this would just be negative 1. Negative 1. Okay. Now, also in this example, we see that sometimes you can use your calculator to get an exact value, right? If I type in tangent of 135, that should give me an exact value, right? Because negative 1 is a rational number. So sometimes you can pull your answer from there. Any questions so far? All right, let's see how our mic's doing. Still rolling. We're doing good. It always works better for this class for some reason. I don't know what it is. All right, so what if we look at number 4? All right, what if we go negative 90? All right, so first of all, sine, we want the y value for negative 90. Here's where we have to kind of use that knowledge from Thursday, right? Because there's no negative 90 on there. Can anybody tell me what angle we would be looking for here? 270, right? So you can kind of see visually, all right, this is 90. So if I went the other way, that same amount, I'd be at 270, right? And if I want the y value, then I'm just looking at negative 1, okay? So sometimes you got to do a little bit more thinking than just finding exactly what it says. So that was negative 1. All right, and then we get into some secant and cotangent kind of stuff. All right, so for this one, example 5, you want to remember secant is inverse of, anybody remember which one secant goes with? Cosine. Very good. You guys are good. You guys are good. So if I want the inverse of cosine, I want the inverse of x. All right. So I could just think of that as 1 over x. 1 over x. All right. So now I go find my 120 and its x value, and then we'll talk about how to do 1 over x. All right, so 120 is here. Its x value is -1/2. So let's go try to apply that. So -1/2. All right, so I want to think about how can I simplify then 1 over -1/2. Okay. Some of you guys will just know that's -2 without thinking too much about it. But if you don't, just remember to multiply by the reciprocal, right? So you can always work that out as 1 times -2 over 1. But that's -2. And again, that happens to be another one that we could just pull right from our calculator, right? If you type in, well, actually we can't. Sorry, we can't do that. So you can't type in, there is no secant and cotangent and stuff like that. There is no button for that. So you can't really check those. So sorry about that. All right, so 6 through 8 are on the filled out notes. We'll skip those for now and finish with 9 and 10. 9 and 10 are just in radians instead. Okay, and that'll be where we leave it for today's introductory video. Okay, so sine, looking at number 9. Sine, I know I want the y value. Okay, sine, I want y for 11 pi over 6. So I go find where it is. Looks like 11 pi over 6 is in quad 4, almost a full turn. And so my y value at that point is -1/2. A quick note before we move on. Now, if I go to check this, so if I type in now sine of 11 pi over 6, say I just want to check my answer, that's not equal to -1/2. Anybody know what I would need to do to make my calculator read this right? Change it to radians. Okay, so if we're plugging in radians, your calculator needs to know that, right? So if we wanted to check this one, we'd go back to radians and then we could type it in that way. So now if I type in sine of 11 pi over 6, it should give me -0.5, which we know is what we got, -1/2, right? Yeah. Yeah, let's come back to that. Let's go ahead and finish number 10 real quick, and then we'll come back to that thought. Okay. All right. So number 10 is again a negative value. So cosine, again, we know we want x here. So x for whatever -5 pi over 6 is. All right, so can anybody tell me? I'll give you guys a chance to think about it. What radian we're actually looking at here for? Because there's not one that says -5 pi over 6. Anybody tell me which one we'd be looking at? You can give me degrees or radians. And again, this is just kind of learning how to use this circle, this diagram. Give you a hint. So kind of visually, that's positive 5 pi over 6. So what would be the opposite of that? What would be going the other way, that same distance around? Taylor? 210 or 7 pi over 6. That's right. So we're going to look at this guy right here. We said we wanted the x value, so then I know I want -√3 over 2. So that's where that angles of rotation work comes back into play. All right, so Cochran, you had a question? All right, so we said sine is a y value, right? And then just find 60 degrees on your unit circle. Did I do it wrong? I guess I did it wrong. What did I write? I think I just wrote it super small. I think it was just hard to read, maybe, or I might have written it wrong. Yeah, I just wrote it. I wrote it super small. So yeah. No, that was. I can do better than that. Square root of 3/2. And then is the other one okay to you, or you wanna look at that one too? So tangent is y over x. Well, on 135. So 135. So we want to use those too. There's a lot to look at on there, So plus I'm going pretty fast and flipping around everywhere. So that's what you want to do is ask, though, guys. Hey, listen, I'm not going to give you the handout that goes with this. That's what we'll do tomorrow, just to kind of make sure you guys have this. So pretty much tomorrow you'll have a chance to reinforce this and ask questions while you're working. So try to remember to bring your notes so you have that unit circle. And I'll post this video when it processes.